What's up, guys? Welcome back to Built for Life. I'm Joel, and today we're talking Christmas. So recently I did a fall projects video where I profiled like 4 or 5 projects that you can make on your CNC for fall to sell or for yourself, whatever. Well, the thing is, I really wasn't invested in any of those projects. They were fun to make. I had a good time. I liked them. I thought they were great. However, they just weren't exciting. And since I'm making these videos, as a hobby, I'm not selling things. I decided to do Christmas a little bit different. Instead of doing a 5 Christmas projects or whatever, I decided to do a more in-depth, um, profile of what I'm actually making for my family. So that being said, we're starting off Christmas with a gift for the ladies in my life. Ladies in my life, I mean my mother, my sister-in-laws, my grandmother, that type of thing. And what we're going to do is make a Christmas ornament. And that was the go-to item in my head that I could think of to make. But I've made Christmas ornaments before on the laser and wood, cut out, and they look great. I just could not get excited about that this year. So I have had a project in the works in the background for a while now, getting all the equipment that I need to make this project. And so I had some new tools that I haven't used yet, and kind of open up my capabilities. So I decided that I wanted to make a metal Christmas ornament. And that's going to be kind of tough for me because I have no idea what I'm doing when it comes to furnaces and melting metal or casting or anything. So I'm learning this whole time. It's one reason it's taking so long to do this video. But I made my mind up. I decided what I was going to make, and so I did all the research, and the next thing was design. So I jumped on Google, started looking for designs, and basically this is what I came up with. It is a letter that represents my family, and the snowflakes kind of give it that Christmas feel and also support it inside that circle. So I had the design. The only thing I didn't know is like what is the thickness of the metal needs to be. I didn't want to go start cutting into my final material and not have an idea of like cut depths or even the correct bits I wanted to use. The bits that I had in my mind, were they going to work? I really didn't know. So that's why I kind of decided to do a good bit of testing before I decided to get into the final material. All right, guys, we're getting into the testing portion of this here. And I decided that I wanted to do a double-sided mold so it would fill from the top and the metal would just pour down. That way you'd have 2 nicely cast sides, front and back, of this Christmas ornament. So here I am just cutting it out of MDF, and that did not work so well. When I got into the detailed portions of the cut, the MDF started, flaking off. I should have known. So what I did is I filled it full of epoxy, I let it cure, and I recut it. Well, finally got it all cut out, and this is when I learned a little lesson about symmetry. So the pins and sockets that I had to line up the mold were not lined up at all. So they weren't symmetrical in the design, so when I flipped the design, it didn't line up. No big deal. This was just a test anyway. I knew where I failed, so I decided I would just cut the pins off and make it work. At least the epoxy worked enough that it didn't flake off. The little pieces right here, they didn't break off like they did on the MDF, so filling it with epoxy and recutting it actually did work. So we completed the test. So I hit it with paste wax, got it all clamped together, and then started filling it with the epoxy. This was a very slow process. The holes I made to fill it, along with the other 2 holes you see there, are just to allow air to come out. And this was a slow process. I wasn't able to like really force it in there. I'm basically just dripping it in there and letting gravity take effect. I should have thought about that. I could have made my fill hole bigger so that that syringe could fit all the way in there and actually put some pressure in there. Probably would have alleviated some of the problems that I noticed when I took the mold apart. But you know, so here there's a couple ways to thin epoxy. One is to do it chemically, adding an acetone or something like that to the mixture to make it thin. And the other one is heat. So here I'm just using my torch, applying it to the outside of the mold to heat the mold up to hopefully apply, make it a little bit thinner so that it would flow through the mold a little bit better. And it worked. As I heated it up, I noticed some bubbles coming out, and then also the mold dropping a little bit, having to add a little bit more. So, you know, in my mind, it worked, and it was flowing a little bit better. Who knows if it actually worked, or if it actually changed anything. But at the time, it made me feel good. So we got all our epoxy poured in, uh, and we let that cure overnight. And the next thing was just to take the clamps off and try to pull this mold apart. So I had to get something to pry this mold apart because it was obviously stuck together. The paste wax, I did the paste wax all over the even the flat areas where I didn't intend for the epoxy to go, but the epoxy was still sticking it together. And yes, I'm using a chisel, but I call this my utility chisel. I use it for things like this or to clean up a work surface or something like that. It's just a inexpensive chisel from Lowe's at Cobalt Tools. I actually have a nice set of chisels, so I'm not destroying or misusing a chisel. I'm using this chisel for the way I intend to use it all the time. Finally, got the mold broken apart to see what we had created, and the only thing that we created was problems and questions. So you can see here it didn't flow to the top, and what I'm started to figure out here is I didn't vent correctly. So there were still areas where air could get trapped, and when you're pouring molds, which I'm newly learning, that can be a problem. So you have to vent all the areas where air can get trapped. So I'd have to vent up to that portion there, or have it be able to fill from that area and air escape from another spot. So this was basically a big failure. And I was starting to question how I was actually going to do it at this point. So I basically scrapped the two-sided mold idea and decided to go with a one-sided mold. So now the double-sided idea just doesn't seem plausible with um, how well it worked out with making the two-sided and um, pouring the epoxy in there. So I decided that I was just going to go one-sided, do it flat, and pour it in from the top, open air. And so to do that, I wanted to start over with another test, but I didn't really have the time to, cut it out, pour epoxy, let it dry. And then ever since I've started doing epoxy art on this channel, I've done several, made a whole bunch of epoxy art, and there's even been videos here on this channel of it. I always save my epoxy in one way or the other, like the leftover. So like I'll pour a color, and I'll have a little bit left over in the cup, and I'll always just usually pour it into a Tupperware container. In this case, I poured it to a Tupperware container, never knowing what I'm going to do with it. Sometimes I even have these silicone molds, and I will pour it into these silicone molds that make dominoes, and I'll actually give the leftover epoxy to the customer that I made the epoxy art for, and just as a, it's kind of funny. Also, my kids love to play with these things, and all I do is, pour the leftover epoxy into that silicone mold, and it pops right out later. We've got some other ideas coming up with that later that I may profile on a video once some point. But at this point, I've decided to go one-sided and start the testing. So you can see here, dumping the leftover epoxy out of the tub. No sides are square, so I got to find a flat spot. So just pulled out the joiner, ran the bottom side across the joiner a couple times to get that flat side, and then use that crush it clamp kit to secure it to the CNC. And here I'm just using a 1/4 inch end mill to flatten it off. I used a 1/4 inch end mill because I wanted to go deeper to speed this up, as opposed to taking off really light passes with a like a large flattening bit. But the goal here is just to get a flat surface to machine onto. Now, anytime I'm measuring or machining on an odd shaped surface, I usually tape out my working area just to give me a place to measure off the working area, and then give me a corner that I can hone my machine to. So that's what I've done here. That's why you see the tape on top of the epoxy. So what I've done is I've taken my leftover epoxy, I've flattened it down, and now I've cut in my design for the Christmas ornament. So what I'm going to try to do now is, another thing that I've never used before is plaster of Paris. I'm going to try to mix it up kind of thin and pour it in here. It says it takes about 30 minutes or so to set up, and I want an actual representation of what the ornament is going to look like. So we're going to try that. I got some mold release. I'm going to spray the mold release on this, mix up the plaster of Paris, put it in there and let it dry, and then hopefully it comes out nicely, and then we'll have a nice representation of what the ornament is actually going to look like when we pour metal into it. I have no idea whether this is going to work or not. That should be enough. All right, so I got some water, mixing it up. The plaster of Paris thing calls for 2-to-1, 2 parts of plaster of Paris, 1 part water. I'm roughly there. Like I said, this is not supposed to be for a finished product. This is for just research, really, I guess you could call it. But I have sprayed our test piece with a mold release, a silicone mold release, and now I'm gonna get this mixed up real good and put it in, and my fear is that it doesn't come out. But we'll see.
I'm also going to put a bunch over the top just to give myself something to pull on or pry on to get this up. Hold it all together, not just the ornament itself. There's no way this is working.
Well, it looks like we did get it worked out. This is the test. Actually, you can see where the old plaster of Paris, as you can imagine, did not come through, did not work. And I think it was just because it was cutting too deep, and I was trying to figure out why is it cutting so deep. And sure enough, my tool paths were wrong. I had a start depth in there left over from another project, and they were all wrong. So it was going 0.1 deeper than what I actually wanted it to. So I got all that fixed. I shaved this piece of epoxy down, and I recut the files to the correct depths. And as you can see, it's in there. And now the image is mirrored because, you know, we're looking at the back of what would be the ornament. So after I get all this cut into the graphite, then we'll be able to pour the metal in there and then pull it out, and you'll see the front in the correct orientation. And yeah, hopefully it works out. I'm doing a lot of testing so that to make my outcomes a lot more likely. But right now it's almost game time for UGA football, so we're gonna have to tackle this another day. All right, guys, we're back out here working on this Christmas ornament. We've done our test. I fixed some problems, and I think I got it figured out. So we're gonna do the final cut. Now, what are we cutting into? So for this, I have a piece of graphite. It's approximately 4 inches by 8 inches and a little over 1/4 of an inch thick. I picked graphite because through my research, it is used in a lot of molds. People who make coins use it, so it has the science part of it is it's the most stable form of carbon, and I'm not going to heat anything up high enough to melt it, so it's a very stable material to use. Foundries use it all the time. So the plan is to CNC the design into the graphite, and then hopefully pour the metal in it. It fills the space that I removed with the CNC. Then I pull it out, clean it up, and have an awesome ornament. But this is, you know, like I've said multiple times on this video, I have no idea what I'm doing. This is all trial and error, and you're learning with me just as fast as I am. So we've got all the kinks worked out with the machine, and I figured out the depths that I want to run. Hopefully it all translates into the metal pouring. So I'm going to get the graphite locked down onto the machine bed and start cutting. One very important thing that I forgot to mention about graphite is it is a conductor. It can conduct metal, meaning that it can bridge a gap and flow electricity through it. What that means for you, if you're running it on your CNC machine, is that it can be sucked up into your spindle or your router and cause havoc inside of that wound motor. So the way I'm going to be running this is I'm going to take my dust collection off to clear the way, and I'm not going to be sucking it back up towards the router. I'm actually going to use my shop vac and basically follow the bit around and suck it into the shop vac, and with the whole goal of keeping it away from the router or any electrical parts. Today I'm using the Carbide 3D Crush It clamp kit. I've done a couple shorts on this thing. I kind of like it. It's kind of nice. It just clamps it to each other. I have the stops, and then these screws clamp to the bed here. And then as you tighten these, it pushes towards the material, essentially, you know, crushing it together so that it's going nowhere. Let's get to cutting. Well, I really don't think this could have come out better. It took a lot of testing to get it to where it is. It came out really well. I was worried that I was going to have a lot of stuff to clean up inside the design, but I don't. And I think a little bit that goes to the way I wrote the tool path. I had 5% step over on all this, so it cleaned up really well. The bits I used for this were a 1/32 ball nose and a 1/4 inch ball nose, both Amana tools. I slowed the feed rate all the way down to 40 inches per minute, and I decreased the depth of cut on each one so that it wasn't taking out large chunks, because I was worried that when it got to like these areas here where it was knocking off an unsupported edge, that it was going to chip or something like that. So I slowed it way down to let the bit eat and slowly take it off rather than pushing through the material. I was worried about that, but I mean, like I said, I couldn't be happier with the way it came out. But unfortunately, this video has already gone too long showing you all the testing and carving the actual mold. So we're going to end this video here. If you're interested in seeing the final product, seeing the casting process, then, you know, consider hitting that subscribe button, ring that notification bell so you can be notified when the next video comes out, and stay tuned for part 2. We'll catch you on the next one.